We might as well look at a couple of more things with this El Nino IOD business. Remember the basic questions of whether it's really a dipole has been debated for a long time. Whether it's really independent of El Nino is another question, but you can see that the papers don't explicitly worry about their independence. They call them their interactions. They call El Nino and IOD as cycles, IOD negative El Nino, IOD positive La Nina, and so on and so forth. This one talks about impact of different types of El Nino on the El Nino IOD relationship. No worries about whether they are independent, but when we say El Nino type, we've talked about the extreme El Nino, which is very warm near the coast and the east. Canonical El Nino is where it's warming around the coast towards the dateline. Central Pacific El Nino is when it's warming around the dateline, and there are also mixed types of El Ninos. I'm not going to spend too much time into the details, but these papers involve quantitative analysis with advection terms, waves, vertical motions, everything, right? Previous studies reported that positive phases of the Indian Ocean dipole tend to accompany El Nino during boreal autumn, September, October, November. Here we show that the El Nino IOD relationship can be better understood when considering two different El Nino flavors. Eastern Pacific El Nino events exhibit a strong correlation with the IOD dependent on their magnitude. In contrast, the relationship between the Central Pacific El Nino events and the IOD depends mainly on the zonal location of the sea surface temperature anomalies in the Pacific rather than their magnitude. CP El Nino events lying farther west than normal are not accompanied by significant anomalous easterlies over the eastern Indian Ocean along the Java-Sumatra coast. So you don't get a trade wind-like structure in the Indian Ocean. And this is unfavorable for the local Bjerknes feedback and correspondingly for an IOD development. So this is what would distinguish it if it is an Indo-Pacific tripole and the maritime continent, West Pacific and Eastern Indian Ocean are responding together, then it doesn't, the Eastern Indian part is not necessarily part of the Bjerknes feedback in the Pacific. If you have separate Bjerknes feedback in the Indian Ocean between the Eastern Indian and Western Indian halves, then you can call it independently behaving in the Indian Ocean. Okay, the El Nino IOD relationship has experienced substantial changes due to the recent decadal El Nino regime shift, which has important implications for seasonal prediction, which means the claim that there are more Central Pacific El Ninos recently, but obviously it's a problem because 2015, 16, 23, 24, 26, 27 are all looking like Eastern Pacific El Ninos. Okay, so here are the El Nino types. We are talking about 1951 to 2009, so before the before the Eastern Pacific El Ninos have come back. So you have EP El Ninos and CP El Ninos, and you can see that, let's see here, EPI red and CPI green during El Nino boreal autumn season. For the 1951 to 2013 period. Note that El Nino years are El Nino events only are shown, not all years. Error bars represent 0.5, etc. So there are also mixed El Ninos. Okay, so these are the indices, and you can look at it as also Nino 3.4 in the Pacific versus the IOD intensity in terms of the DMI, and obviously El Nino 3.4 can get much stronger than DMI ever gets, and you can see when you look at all El Nino events, you get a correlation of 0.67. The weaker IODs are kind of flatter here, very weak, but still they are identified as IOD, so literally they are at 0. For Eastern Pacific events, the correlation jumps to 0.96, but obviously number of events drop. As I said before, sampling can be an issue. If you look for CP events, the correlation drops to 0.6. and these are all CP events, and this is based on CP zonal location. Then the correlation jumps to 0.93, so you have to separate out certain El Niños which are listed here as EP and CP events. You want to go into this kind of detail, or you want to just worry about the processes, because these are correlations, but they do show what the mechanisms behind them are, and that's something like this. If you have strong EP Eastern Pacific event, then you have during this is obviously during the IOD, so you have divergence over the maritime continent. So you have cold SST anomalies, cold rainfall anomalies, and you have westerlies or the easterlies, like trade winds here, which favor upwelling on this side, and you have the warm pole on this side, and you have the westerly or weaker trade wind anomalies on this side. But if you have weak Eastern Pacific event, then you don't have such a strong reaction on the Western Pacific maritime continent, Eastern Indian Ocean, and you don't have a very strong IOD-like response here. If you look at East World Central Pacific event and Westward Central Pacific event, then you have really not that much difference. You have warming here more towards the east of the dateline, whereas here it is moving west of the dateline, so you can see it's more spread out, and it has this Pacific meridional mode kind of relation with wind anomalies also showing up here in the subtropical ocean. So they argue that these are different as well. So depends on the strength of the El Nino and the location of the El Nino, and sometimes the strength matters based on the flavor, and the other times it doesn't matter. So just jumping ahead to the conclusions, they say another previous study displayed high there are lots of other figures shown here with the vertical motions. Obviously, when you perturb the Walker cell, you are going to get rising anomalies here, sinking anomalies here, and rising anomalies here. So the entire thing shifts, and similar thing here to the extent that this is IOD, but you have the convection moved only to around the dateline or slightly to the east. You can see there is still a warm anomaly signature here in autumn, but this one doesn't have it. So when it moves too far west, you even get cold anomalies here, whereas this you can think of it as maybe a mixed CPEP El Nino. Okay, I'm just putting this here because I want this to be somewhat of a complete collection, but not being a little lazy about explaining these. So another previous study displayed a high consistency between ENSO amplitude and the ENSO IOD correlation, especially exhibiting a simultaneous decadal enhancement around the late 1970s. Before that, there were also papers, before people talked about correlation between an ENSO and IOD as soon as IOD paper came out in 1999 or so. And then people showed that SON correlation with ENSO is very strong, hence IOD is not independent, because if you do overall correlation, that correlation is weak, which was argued to claim that IOD is independent, and so on and so forth. So this is consistent. Their claim of ENSO amplitude and ENSO IOD correlation is consistent with the EPI IOD relationship in the study. However, this consistency may be weakened due to more frequent occurrences of CP El Nino events in the recent decade. This is very much dependent on the period they used for their study at the time. By now, people don't believe that CP El Nino events have really increased because of global warming, for example. The study also sets a further challenge for forecast models to accurately predict both the amplitude and location of El Nino. Our earlier work suggests that impactful teleconnections greatly depend on whether a CP or EP El Nino occurs. But here we go further to suggest that the location of the CP events themselves causes a great variation in the connection to the Indian Ocean. So they are saying CP El Niños are not monolithic, that they also can be more westward extended or situated more eastward. Further efforts are thus required to more realistically capture different El Nino features in coupled climate models, although considerable progress has been made. But you understand what is missing here is whether El Nino itself is impacting IOD, or IOD is feeding back to El Nino, or El Nino is just correlating with IOD. In this case, it implies as if IOD is a response, and so on. So basically, we are not really answering deeper questions. We are just taking past events and trying to make correlations out of them and find consistent processes that can explain the correlations, especially in terms of what happens over Western Pacific Maritime Continent and Eastern Indian Ocean with the divergence. There are also Rossby waves and Kelvin waves involved. The key thing is if there is indeed a Beekness feedback in the Indian Ocean, which is of course possible when the events are very strong, like the 97-98 IOD, which made the biggest news, then you can imagine that the maritime continent and Western Pacific have kind of separated out from the IOD. Okay.